All right, welcome to CS107E. And CS107E is a course that actually can replace CS107. Most of you guys know this already in the curriculum. And I'll spend a little bit of time talking about the differences between 107E versus 107. The biggest difference is that instead of typing on a computer, your computer that interfaces with a computer in the next room over, no matter where you are on campus, it's that room, you will actually be using a Raspberry Pi, and every bit of code that you write is what is running on this Raspberry Pi, and that's actually pretty cool. This class is a little bit of computer science. Well, it's a lot of computer science. It's a little bit of electronics. It's a little bit of electrical engineering. It's a little bit of project design. It's a little bit of lots of different things, including a lot of coding and a lot of very low-level coding, which is similar to 107, except that we flip things around. 107 starts kind of high and you gradually go lower in the system. In our class, we're going to start at the bottom and gradually go up. And it's going to be an interesting class. I taught this class last quarter. My name's Chris Gregg, by the way. I taught this class last quarter and loved it. I thought it was a fun class to teach, and the students, for the most part, thought it was excellent too. They didn't necessarily realize how much they were going to work during the quarter, so keep that in mind. First thing I said is you're going to work hard. But it's a very fulfilling class, especially if you are interested in both the computer science programming aspect of things and a little bit of the hardware sorts of things. Are there any freshmen in here? No freshmen. I saw one or two enrolled, so maybe they decided they couldn't. Either they couldn't find the place, or they decided not to. But this class is open to anyone. You probably should have 106B before you get here. If you don't, please talk to me after class. If you took something equivalent somewhere else or something like that, you do need to be a fairly good programmer to take this course. Okay, we will get into lots more details today, but welcome. Hope you guys are going to enjoy this class. I think it's a great class. All right, who are the people that we are going to be, who are going to be helping you during the year? Well, I'm Chris over there on the left. We also have Jennifer in the back. Jennifer, raise your hand. Jennifer is a graduate student in electrical engineering. We have Jane also in the back. Jane is an undergraduate studying what? Computer science, right? Yeah, it is computer science. Okay, I thought Keith is your advisor. Yes, correct? Keith Short? Oh, that's right. Mary is. I forgot. Anyway, Jane is an undergraduate. Took this class 2 quarters ago, or well, 2 times ago when it was taught, or maybe 3 at this point. But she's the one who has the most experience with this course in this entire room, as it turns out. And then Eric is in the back. Eric, raise your hand. Eric's also a graduate student, brand new to Stanford this quarter, so welcome, Eric, also in Double E. And then Matt, who has another class right now, is also another undergraduate who took the course previously. So honestly, the 2 people that are going to know the most about the assignments and the ones who are going to have the most real knowledge about the actual coding of the assignments are Jane and Matt, and they're the undergraduates who actually took it. The rest of us, obviously, will know all about the assignments and so forth, but I'm just telling you, they're going to know the itty-bitty details that we may not know. That's that. Okay, who am I? Who took a class from me before? So good to see you guys again. You've seen this slide before, if you took a class from me before, but a little bit about me. I graduated lots of years ago from Johns Hopkins University, Bachelor of Science in Double E, so I do have an undergraduate degree in electrical engineering, which is one of the reasons I wanted to teach this course. Then I spent about 7 years in the Navy on active duty. So I went straight from college to the Navy, got to see the world, got to live in Australia, got to live in San Diego. It's why I'm in California now, is because I love San Diego and California in general, and because Stanford's so cool. So I did that for about 7 years, and then decided, I think I want to go do something else with my life. Perfectly fine decision, I think. And I decided to teach high school physics. So I went and got a master's degree at Harvard in education to teach physics. And I had 7 years of teaching high school physics in both Brookline, Massachusetts. I don't know if anybody's from Massachusetts. Are you from near Brookline? I'm from New Hampshire. Oh, you're from New Hampshire. Very, very southern. There you go. Lots of people commute from there to Boston, that sort of area. And then I taught in Santa Cruz. Anybody from Santa Cruz? Yeah, well, nearby. I taught at a little school there called Pacific Collegiate School. And that was great, and I loved it. I decided I wanted to end up getting a PhD, so I decided to apply for a PhD. Ended up at University of Virginia. Anybody from Virginia? Oh, no kidding. Normally a couple. And then I got a PhD in computer engineering, which, by the way, is kind of between computer science and electrical engineering, which is exactly what this class is all about. Now, we're not doing computer engineering, like we're not designing the computer parts, but I feel very much at home in this class because of that kind of thing. And then I ended up going to Tufts University in Boston, teaching there outside of Boston, teaching there for about 3 years, and then I landed here in the fall of 2016, so I'm actually a junior right now. So I love it here. I can't imagine doing a better job. I love teaching. I think it's the most fun thing in the world. I love interacting with students. You will see me in all the labs, and I will hopefully get to know you, and you'll hopefully get to know me as well. So that's me. I have an obligatory picture of my 2 dogs, Juno and Jupiter. We got Juno last week, and so she's a little shy right now still, but believe it or not, Jupiter's a puppy. Juno's 2 years old, so we kind of did it in the reverse order. But Jupiter still can't figure out why this other dog's in his house. But they seem to love each other, so that's good. All right, what is this class all about? Well, first things first, the learning goal from this class. Oh, and by the way, this may or may not be make you happy, but class on Axis says we go from 11:30 to 1:20 or something like that. We actually go from 11:30 to 12:50. So I'm not going to keep you here for the full time, and it is Mondays and Wednesdays. Just so you know. I'm sorry, Friday. Thank you. Okay. Mondays and Fridays, not Mondays and Wednesdays. Thank you. I was testing you. Okay, so what are the learning goals of this class? Well, the learning goals are basically understand how computers represent data, execute programs, and control peripherals. Like, what does that mean? Well, when you took CS 106A or some, AP class in computer science, you learned about programming, right? And then you took CS 106B and you learned about making programs efficient. You learned about n squared and logarithmic behavior, and you learned about hash tables, and you learned about all those kind of things, and linked lists and all that. And now we're going to have to go another step lower, and we're going to learn about how computers actually represent data. Like at the very basic level, how do you get data on a computer? And honestly, it's ones and zeros. And it's ones and zeros because of transistors, and that's the way it goes. But we'll have to understand that part of it. Then we'll have to understand how the computers actually execute programs. And this is interesting. I mean, you may not have ever thought of that. When you press the little green button in Qt Creator, right, it just kind of runs your program. But we're going to have to think about what does that actually mean at a very low level. We're going to end up talking about linking programs and how the program actually gets loaded onto the computer and where in memory it is, like the actual address in memory, things like that. By the way, you don't learn in 107. You kind of don't worry about that level of granularity. But here we're going to. Okay? And you also have to learn how to control peripherals. This is the other big difference between 107 and 107E. Peripherals are the things that connect to your computer. You probably didn't think about the fact that when you were running a program, there was a keyboard connected to the computer, right? You didn't think about that. You typed the keys, whatever, right? Well, now we're going to have keyboards, and the keyboards are going to be connected to pins on this little Raspberry Pi, and you have to program all the details about getting the keystrokes off the keyboard into the computer. And it's actually kind of like there's a lot to do in that sense. Now, we have documentation that tells you how to do this, and we're going to walk you through a lot of this stuff. But that's the level we're talking about, right? Like, literally, we're saying, okay, here's 3 or 4 pins connected to our Raspberry Pi from the keyboard. How does a signal get, when we press the key, into the processor? And there's lots of, like I said, documentation and things about how that works. So that's learning goal number 1. Okay, anybody know what this is? It is a rocket. It is a Saturn V rocket, which is the kind of rocket that sends things like astronauts to the moon, and it's big. Notice how big it is, right? It's ginormous, and it is interesting in that the actual rocket itself is about 6.2 million pounds. It's got a little command module on it, which is 64,000 pounds, and then you can put a payload in it. That's the stuff you actually want to go to space. Right? You don't care if the rocket goes to space. You care about the stuff it's carrying goes to space, right? And we can only put 1.5% of the total weight of the thing into space. In other words, it's not particularly efficient. So, but it does the job and it gets things there. But it's, we gotta land the things in the water, and then you can't really reuse them. And take millions and millions of dollars to refurbish them if you want to reuse them and whatever. Anyone know who this guy is? Elon Musk. He's been in the news lately for some, he's lost a little bit of his shine lately. But Elon Musk created a company called, or was part of the creation of a company called SpaceX, which designed this rocket. Now, notice something about this rocket. It's actually a fair bit smaller than the Saturn V, number one. Okay, I mean, the perspective is a little different too. It's called the Falcon 9. And Elon Musk is an engineer. He said, look, we've got this Saturn V rocket, it's awesome, but it can only take 1.5% of its weight into space, right? And that's not very efficient. What if we get some really smart rocket scientists together and we said, let's redesign the rocket to make it so that it can take 5% of its payload into space. Wow, if we do that, we will be able to send much more, because it's really expensive to send things into space. And then he said, well, if we actually make it like 4%, we can take that other extra 1% of weight and put things like fins on it. And when you put fins on a rocket like this, you can do cool things like you can actually have it land. Now, you guys have probably seen this, and I didn't test the sound. I'm hoping the sound works. But let's see if I can bring this up. This is one of my favorite videos. If you've seen it, great. If you haven't, it's kind of a treat. And let's see. Jennifer, could you just throw the lights over there so everybody can see us? Thanks. This is going to be the after one of the launches. And there, thank you. And let's see if it... No, well, you'll have to listen to it here. That is the crowd screaming because it's so intense and so awesome. There's the rocket on the top right coming down. The top left is where it's about to end up.
And that landing burn has started. Both boosters looking to be on track towards their respective landing zones.
There's the rocket, and guess what? That's the baby rocket. There's the other rocket right next to it. They landed two rockets vertically next to each other.
It's landed.
Which was amazing, by the way. I was on my toes the whole time, at least at the end after I thought they'd come back, which they did. But if this doesn't get you excited about technology, like seeing things like this, like nothing will. Okay? I mean, being able to take a rocket, send it to space, and then land it again vertically is mind-blowing, right? Now, how did this end up happening? It was because a smart engineer knew the system that he wanted to build, hired a whole bunch of other people, and they built it, and they made it more efficient, and they just used their smarts to do that, and now SpaceX is the go-to people to send things into space, and it's cheaper, and they're more efficient, and they've got all these great, programmers that do all sorts of cool stuff like this. Now, this is not showing you that 15 times they crashed, right? You can go look those videos up too. This is, just as I said, I think it's the coolest thing. And this is the kind of thing that we're not going to be doing rocket science, but you're going to be learning how to do stuff that needs to be more efficient and needs to work well because you only have a certain amount of the certain system to work with, and you got to make the most of it. And that's a lot of what this class is all about. It's very technical, but it's also about, hey, you've got this thing here. You need to know the ins and outs about it, and you can make things more efficient and so forth. There they are landing. A picture of that. And I think the fact that they had the baby one coming in too is awesome. Okay, what does this all mean? Well, mastery is power. If you master your computer and building things for it, okay, you can land rockets, okay? And it all comes down to understanding those sorts of things. This class, this is a Raspberry Pi. This is actually not the version that we are using. If you want to come look at it later, it's got more USB ports and so forth. The version we're using is on the table here, connected to everything, and I wasn't going to disconnect it because there's lots of wires. I don't want to screw things up right now. But we are going to be doing bare metal programming. Jennifer, I think you hit the lights thing. We're going to be doing bare metal programming, which means that this device is not going to have any code on it that you didn't write. In other words, it's not going to run any code. There is not an operating system. If you go and buy this computer at the store or Amazon or something, the first thing you do is you look up, how do I use my Raspberry Pi? And it says, oh, install an operating system on it, right, on this little SD card. that goes there. You install the operating system, and then it runs like you're an operating system. It's got a GUI, and you can use a mouse, you can connect a keyboard, and all that. This is not this class. This class is no operating system. You write code that runs on here. Now, that means that it's going to be a little bit intense. It also means that debugging is going to be hard. Right? We'll talk a little bit about that a little later. Okay? We'll talk about that a little later. But the point is that you are going to either boot a program off of the little SD card, which is the first lab. You're going to do that for the first lab. And then after that, that's kind of annoying because you got to take the little thing out, you got to plug it into your computer, you got to load the program on, you got to take it out again, then plug it into the Raspberry Pi, and then turn it on. There's a better way of doing that, which is called a bootloader, which you'll learn about in Lab 0 or Lab 1. And that is going to just be a connection from your PC that just sends the program to the Raspberry Pi and then starts running it. So I kind of lied. There is one more piece of code running on here, and that's the bootloader that's going to basically take your program and make it start running. Okay, we wrote that for you. So that's that. But that's what this class is all about. Okay? There's the Raspberry Pi. That's the one we're going to be using. Okay? A couple things. I'll talk more about this on Friday. This is the processor. That processor is, it's called an ARM processor, and it is kind of the main thing on the computer. But there are other things that are interesting. It's got a bunch of pins up the top. That's where you can connect things like LEDs, and you connect the keyboard, and you connect other sensors and things, or a speaker, or a temperature sensor, or something like that. That's where you connect it, and that's where you actually interface up there. So that's where the double E side of this class kind of comes in, where we're playing around with electricity. If you connect some of those pins in the wrong way, your Pi explodes. Well, it doesn't actually explode, it just dies. Then you got to get another one, and that's annoying. So be careful. Just, follow the directions and don't, plug wires just in random places. Know what you're doing. It's not too hard, actually, to blow it up, but I will leave it at that. It also has a couple other things, like a power cord, which we are actually not going to use because we can power it from one of the pins. It's also got USB, which we are also not going to use. The USB port on the Raspberry Pi, well, USB is a hard device to interface with. It's just got a lot of things going on, and we don't have any libraries that interface with it, so you just can't use it. Too bad. You don't need to. The keyboard we have is an older keyboard that doesn't use USB, as it turns out. So we're not going to use that. It does have an HDMI port, which is the monitor. We will use that. And it's got a sound output. You may use that for projects if you want to. We'll show you a little bit about that. And it's got a couple of other things in here. There's a camera. I think this is the camera over here. And it's got some other display. It's got a little SD card and so forth. And that's the computer. But it really is a computer. And it really can run an operating system. And it really will run your software. So that's kind of cool. Okay? Here's the total kit that we're going to give you. You actually aren't going to get an HDMI cable or a connector. Those are going to be in the lab, stay in the lab. But you're going to get the rest of this. You're going to get a Raspberry Pi, you're going to get a breadboard. If you've never seen a breadboard before, don't stress out. You can learn this electronic stuff relatively quickly, the stuff that we're going to talk about. Okay, if you don't know what transistors are, oh my gosh, I don't know what those are. It's okay. It just means a little bit more learning. People who are double E's have seen a lot of this before, so I suppose in some sense you get a little bit of an advantage there. The CS people, you get an advantage because you're probably better coders. No offense to the double E people. But this is the thing. We've got lots of wires. This is the serial device that connects into your computer to the Raspberry Pi that transfers the programs back and forth. And a little display we use for a fun program. We've got lots of LEDs and resistors and buttons and so forth. And that's your kit. Okay. The kit costs $50. It's going to be done through Access. If you need to get some relief from that money, let me know. We'll try to figure that out. But otherwise, that's what you get for the kit. Okay. This is how it looks when it's connected into your computer. Not that that's very interesting, but by the way, your breadboard is actually breadboard on here small. Yeah, this is small. We give you a bigger breadboard, so lots more places to connect stuff up. And then you can connect things like this, lots of wires and things, and try to make yours look nice. They don't always look nice. It's a little tricky. If you've done any of this before, you look and it's like a rat's nest of craziness. But the easier it is to understand, or the simpler it is in layout, the easier it is to debug. I'll tell you that for right now. Okay. The goal of this class is to have you build a set of programs, and those programs will start to build up the various things that your computer can do. Okay, we'll start by doing some assembly language, which is machine code, to actually blink some lights. You'll see that for the first lab and first assignment. And then from there, you start building up until we get to a shell. Now, a shell is, if you haven't seen it before, and if you've taken like 106B or 106A, you didn't really use the shell. The terminal is what's called in a lot of cases. But what that is, I just pulled the one up on my computer, on my Mac, and it's just a program called Terminal, and it allows you to type commands into it like ls, which will give you a listing of all the program or all the files in your directory, right? You can have other cool commands like cal, which gives you a calendar, and things like, let's see, what are some other interesting ones? Who tells you who's logged on. Okay, I guess I'm logged on a zillion times for some. Oh, I have all the terminal windows up. That's what it is. Okay, you can say like uptime, which tells you like how many days has your computer been running before you think things like that. But it allows you to do that. And you can also run programs from here, and you can troubleshoot. And you can do things from the command line. And you are going to have to be very used to this on your computer. Okay, excuse me, I'm fighting a cold. You will also have to be, or you will also be designing, or building, I should say, a console for your Raspberry Pi. Okay, let me give you a demo on that. Okay, let's see if this works. I'm going to throw in a lozenge here, so I apologize for looking like I'm chewing something. When you turn on the Raspberry Pi and you have it hooked up to an HDMI monitor, this is what comes up. Nothing's really running on it right now. It just comes up in this nice pattern here like this. What you can do, I will switch back for a second. What you can do is you can, and you will, on your computer, you will type a command called make install, and you're going to type a bunch of other commands later, which will take the program that you've written and send it to the Raspberry Pi like this, and it's going to do this, and it's going to do the little dot, 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 and say sent. And then what happens, hopefully, there we go, successfully sent. And if we go back to what's running on the screen, if everything worked right, ta-da! There is your console. Now, by the way, I've got a keyboard on my computer. The keyboard I've got connected to the Raspberry Pi is the one I need to use. You will forget that 1,000 times. Right, Jane? You forget about 1,000,000 times to use the keyboard on you're trying to do it on a computer and you're using the wrong keyboard, you'll forget. But eventually you go, why is it working? And you'll be typing over here, and oh, because I'm dumb, right? Oh. Now, what is this console going to be able to do? Well, first of all, it's going to be able to print stuff on the screen. Now, you think, oh, that's easy, print F, blah, blah, or C out, or whatever, right? No. Well, first of all, you will write printf, right? You actually write that function, it turns out. But you also have to write some code that takes the actual bitmap, in other words, the image of each character, and tells it how to put it on the screen in the right place. Okay? That's the level we're talking about. Not just like, oh, just print stuff on the screen. You have to build up to the fact where you have to get letters on the screen that we've given you a file that describes all the letters. You need to write the code that actually places the letters on the screen in the right place. Not trivial. Okay, not trivial to do. Not possible, because you're going to do it, but not trivial. Okay, all right, where was I? Oh. And then you're going to be able to interface with the keyboard, H-E-L-P, and it's going to give you a whole bunch of things to do that it can do, and all these things you're going to do. And you can do things like echo. If you say echo, hello, the one I have is not perfect because it's like the previous assignment to the perfect one, but sometimes the keystrokes get lost. You'll see why when we get there. Hello world, W-O-R-L-D, there we go. And then it will simply print hello world to the screen, and that's that, right? You will be surprised at how happy you are when it does that. Right? You're gonna go, oh, I did it, right? You're gonna jump up and down, and your roommate's gonna, what's going on? Why is it 6 in the morning and you're still up? And right? And you're gonna be surprised at how much, how impressed you are with that. It also does things like peeks at memory addresses, right? You're going to be able, which means tell me what that memory address. So let's try something. Peek, the odds this is 0 is very, very high, but peek 0x, I don't know, 0x1000. Oh, there we go. Look at that. The 1000. And by the way, 0x means hexadecimal. You'll get to learning all that soon. Okay? Hey, Matt. And then that's Matt, by the way. Thanks for coming out. And then you can peek, which means tell me what is at that address. Or you can poke something there. You can say, hey, poke 0x1000 with 5. Right? And then if we run peek again, by the way, you also do the arrow keys up and down, so you can actually get back to the peek 1000. Now it should say 5, and it does. Okay? Things like that is what you're going to do. Like I said, this seems very simple. It is a lot of work to get to this point. Okay? A lot of work to get to this point. But that's one of the end goals. Now, this is the goal for before your final project. One thing and one reason you may be taking this class, there are no exams in this class. This is a completely assignment-based and project-based class. Okay? The final project is the last 2 weeks of class. We're still dealing with we're trying to figure the schedule out because Thanksgiving is in there as well. But you actually, turns out, the presentations aren't until the Friday of finals week. And like half of you might get up and be like, I'm not staying that long. But you do have to be there. But it's the final project is anything you want to do using your Raspberry Pi that impresses us, right? And it's a lot of fun, and you will have a blast doing that. So that's a console that you're going to get to. There we go. By the end of class, and we will go back up here, and that's the shell that you're going to end up running. Okay, there it is on the screen. Learning goal number 2: mastering your tools. Right? We have lots of tools for this class. What do I mean by tools? There's compilers, there's assemblers, there's linkers, there's lots of other. There's the program the tool we use to send the program to the bootloader, to the Raspberry Pi. You need to master that, right? There's also lots of things you need to know about your own terminal on your computer, which I described a little earlier. GCC is the compiler, things like that. We will get into all of that as we go along. Okay, Git and GitHub. Who's used GitHub for something before? Many of you. Some of you maybe not. If not, no big deal. You will learn it, and it's not. We give you all the commands you need to know, so it's not too bad. It's the CAs and I that need to know it because we need to do lots of like background stuff for you. Here's some more tools. These tools are things like wire strippers and a multimeter and other wire and so forth. The more, like, these are the hardware kinds of tools. Because remember, you are going to be interfacing wires and things on here. I might suggest at some point getting wire strippers and getting like a multimeter at some point. Don't buy like the $6 ones. You know, they're a little too cheap for. They work for electronics, but don't try to plug them into your house current. I blew one up one time doing that because it was $5 and whatever. But those are some tools. Speaking of tools, take a look at this tool setup here. This is a wood shop. Dan's wood shop. Notice how nicely laid out all these tools are. There's like 7 different types of planes, and there's lots of different tools for different things. You got to know your tools in this class. And by the way, keeping them in the right place is good too. We've got a cabinet where we want you to put everything back, and after lab we want everybody to clean up and whatever. But it's nice to know your tools and have them ready and available, and whether they're software tools or hardware tools. Okay? And you got to keep them organized. Anyone know who this is? Don't look. It doesn't work when I do that. This is Julia Child's kitchen. Julia Child being the famous American chef who cooked a lot of French food and then turned lots of people on to good cooking. This is her kitchen, and it's now at the Smithsonian Institute. And you can go see her kitchen, like in exactly this state. It's kind of cool. Notice she has one of these walls with all her tools down there too. Again, very like well set up, organized, that sort of thing. You have to be that way with your own tools. Okay, and then finally you have to master the craft. Mastering the craft of this class. It used to be that when you mastered it, when you tried to become a master of some craft, you had to go and do an apprenticeship, and you had to go and like learn things. And in that apprenticeship, you swept the floors for like 6 months, and then you did, you were like cutting 1 block of wood, the same exact thing for 6 months. Anyone ever seen the documentary Jiro Dreams of Sushi? Only a couple of you. It is great. I think it might still be on Netflix if you can have access to that. It's a great documentary about this Japanese sushi restaurant owner who has the best sushi restaurant in the world, 3 Michelin stars, which is the most Michelin stars, by the way. And here's how it works. You walk into his restaurant. You have to sign up like 3 months in advance for a reservation. You walk, maybe even more, maybe a year. You walk in, you sit down. The gyro himself serves you sushi. He serves you a piece, and you eat it, and you go, wow, that's the most amazing sushi I've ever had. Then he does that a few more times with a bunch of different sushis. 15 minutes later, you stand up, you pay, it's $300 by the way, and you leave. And people clamor to go to this restaurant because the sushi is so amazing. Now, how is it so amazing? Well, the guy's 85 years old, and he's been doing it since World War II. And he is it's his entire life. He hires apprentices for him. The apprentice gets hired for the first, 2 years. He makes rice. That's what he does. And he washes the rice. He does all different things to make the rice. He hires people to specifically go and buy the fish every day at the market. And he's got the guy that knows all about a certain type of fish. He's got a guy who knows about another fish. He's got a guy who knows what rice it is. And by the way, if the rice isn't perfect, he won't have rice that day. He does something else. He's just I can't deal with the raw. It's got to be absolutely perfect for my restaurant. That's called mastering the craft. We want you to be maybe not quite that level, but we want you to be able to really understand this stuff. And that's kind of the whole point. Okay, I mentioned debugging a little earlier. Well, we're going to be writing in C, okay, not C++, not Java, not Python. We're writing in C, and also assembly language. We are going to be writing in assembly language. Once you know C, C is actually a great language. It's very small. There's not too much to know about the language itself. It's not dead easy, but it's pretty knowable. Unlike C++, which is enormous. And it's easy and fast to write good code in C once you know it. But debugging, takes up 80% of your development time. All right? Why? Because we're dealing with complicated things, right? So you write something, why isn't it working? Well, then you have to debug it. We do not have debuggers built into the Raspberry Pi. Remember, unless you write a debugger, you're not getting a debugger, right? We do have debuggers that will work in emulation mode, so you can run it on your computer first and kind of see what's going on. It's not going to be perfect. Really, debugging is this. You push the program over to your Raspberry Pi, and you look at it, and if a green light blinks, it means it's working, and if a red light blinks, it's not working, and that's what you get. That's your debugging. That's why debugging is a little bit crazy and frustrating and so forth, but you need to learn to, A, write code that's not very bug-prone, because you're not going to be able to debug that very easily. Also, you have to start picking up on the intuition of, wait, this is not working. Oh, I got to go here and look. Here's the first place I go. That kind of intuition is super important in coding for whatever you're coding on. And then finally, debugging really is the learning part, right? You write some code, it doesn't work, and you go, man, I debug it. That's when you start going down this path, and this path, this path. That's when all the connections in your brain start working. Okay? All right. Let's talk about course topics. Before I do that, let's see. Jennifer and Jane, did you count? Yeah. Okay. Who here knows that this class is limited to 40 people? Right. There are fewer of you than 40 here, so you're all in the class. Okay? Now, we still need you to fill out a little application. Here's the other thing. There are only 2 lab spots, and they're weird times. Monday, 1 to 3, and Friday, 9 to 11. Sorry? AM, yes. Not PM. Not PM. So hopefully you can find one of those labs. If you want to be in the class, you've got to pick one of those labs, and we will do our best to get you into those labs. If you can't do it, you've got to take some other quarter, unfortunately. Nothing I can do about that. Labs are mandatory, and you have to go to either of those 2 labs. But like I said, showing up today, fill out the application, you're in. We don't have to make any big decisions, which is great for me because I hate telling people they can't take a class. But that's great. If we do end up with less than 30, we might be able to let a couple other people in if they're really nice, or less than 40. But that's it. Here's where you go to find the information about the course: cs107e.github.io. Okay, and don't bother going there right now, but you can write that down. You can go there later. Here's the topics. I'm going to go over this relatively quickly. We're going to start talking about the ARM processor and the memory architecture. That little processor in the middle of the Raspberry Pi is an ARM processor that's distinct from an x86 processor, which is on your computer or in the labs or whatever. And it's a relatively straightforward processor. In fact, all your friends in 107 are going to go, oh, this assembly language stuff is so complicated. You're going to go, it's not that bad. And they're going to go, oh, well, you're doing ARM. Well, you're going to know that. But Anyway, ARM is different architecture, which means it has different machine code instructions, and they've actually done a better job, I think, than the x86 code. Okay, we're going to learn about that. We're then going to start learning ARM assembly language, so you can write your first programs that make lights blink and so forth. You will not write too much assembly language code after the first couple weeks of class, because we want to jump into C, which is a much better language to write these things in. Then we'll talk a lot about C, and if you were a little wary of pointers in 106B, you will quickly get over that, or you'll have a hard time. Pointers are just naturally what you have to deal with in this class. A pointer is just a memory address, and you will get very familiar with all the different syntax using that and how it actually manifests itself. We're going to talk about C functions. We're also going to talk about serial communication. That's communicating between like the bootloader and your Raspberry Pi, or the keyboard and your Raspberry Pi. Serial communication is interesting. We're going to talk about some other cool serial communication things as well. We're going to talk about linking and loading, which is about how the program actually runs on your Pi. I think that's a little more esoteric, but it's interesting nonetheless. Then we're going to talk about memory allocation. You guys remember new and delete from CS106B? You are going to write an equivalent for C called malloc, which is very similar to C in that sense. Or it's similar to the new and delete, except you're going to have to write that, which means you have to understand the memory system very well. It happens to be the last project generally in 107. You're going to do it a little earlier, so it's not going to be quite as intense. Okay, that's that. Then we're going to talk about the other things we're going to connect to here. The keyboard, like I showed you earlier. Graphics, right? The graphics are, this has a GPU on here too, a graphics processor. You're going to learn how to interface with that, and it's interesting. And then we're going to talk about interrupts. Interrupts are such that your computer can react to things very quickly. If you're doing a loop where you're calculating something, unless you use interrupts, all your computer can do is calculate something. So if you go and hit a button on your keyboard, nothing's going to happen while it's doing that calculating. So you have to figure out how to do that. So we're going to talk about those three big things, okay? And as I said, the final goal is to build the Raspberry Pi shell. Okay? All right. What other additional topics? We're also going to talk about sensors. Like for your final project, you're going to want to make it cool. You're going to want to interface it with something, and that's where sensors come into play. Right? It could be speakers. It could be a little remote control car that you connect to. It could be an accelerometer to tell where in space, or a gyroscope, like what the orientation of your Pi is. It could be there's an innumerable number of sensors that you can go. I once had some students work on a project where they took a UV sensor and connected it up to their computer. It wasn't a Raspberry Pi, it was an Arduino in the class, that other class. But they connected the UV sensor up and then built a whole project around it where a kid could wear a hat that had this sensor on it, and they could go outside in the sun, and then the sensor would pick up the UV rays, tell how much there were, and then text the parents and say, hey, your kid needs more sunscreen. Right? That's kind of a cool project. I wanted them to actually build it out for a real project. It's kind of cool, right? And then we're going to talk about like what types of things do we need to do for Linux and so forth. The follow-on class, one of the follow-on classes to this class, CS110, goes into a lot more details about running things in parallel and about running things. And I'm actually teaching that next quarter and in the spring, so I may see you guys again if you go from here to there. And then after that is CS140 or CS140E, which is operating systems. And then you really get into the down low about how operating systems are built and what needs to go into actually making a whole operating system run. And then we're going to have a special guest lecture. We haven't actually decided exactly when or who that's going to be, but we will let you know, and it should be, it's always a lot of fun. Okay, a couple admin things here. Weekly cadence. So each week has kind of a topic, okay? It's going to be basically Friday, Monday is the topic that we're going to talk about. The way the labs are set up, it's not perfect for the way the labs are set up. It turns out the Friday lab is before lecture, the Monday lab is after lecture. So it's almost like the Monday lab people get a little extra time to process before, or they get a little extra knowledge. But we're going to try to make it so that you don't have to. It's not going to make a big difference to you. I think the Friday people will actually get a little more time to do the assignments because they're going to be due the next Monday. So it's just a toss-up about what you think. But as I said, the labs are either Friday 9 to 11 or Monday 1 to 3. I think that's what I said. It's in Gates B21, which is around the corner. You will find it. And then we're going to have the assignments due the following Friday. Remember, labs are mandatory. Coming to class is also mandatory. Look, if you need to miss class for a day or two, you just tell me and we'll figure it out. A lot of times I will do a screencast, and it's not like we're going to like dock you points if you miss it. If you miss it every week, though, yeah, I'm going to start saying, where are you? You decided to sign up for this class. You should be here. That's just the way it goes. Okay. For labs, this is also, sorry, that was lectures. For labs, you got to go there. There are exercises and a checklist you have to complete. Really, the labs are to get you used to or get you ready for the next assignment. That's the basic idea of the lab. And we will have lots of people there. There will be at least 3 of us there every day in lab. I will be there, and then 2 TAs will be there, so that's great. You'll have tools and supplies and soldering irons, and you'll have the wires and the wire strippers and all that. And as I said, there's a kit that you get to keep with the Raspberry Pi and all the different parts. There are 7 assignments. They build on each other. There's a basic part of the assignment, which means you are going to do that for the grade to begin with. And then there's extensions, which are just like 106B extensions, where you have other things you can work on. Part of this class, though, your grade is going to depend on how many of the extensions you end up doing, right? So if you do lots of the extensions, you will probably get a better grade than if you do none of the extensions. It's not to say you can't get a B or so if you end up doing no extensions, but you're probably not going to get that A to do so. We'll have more details about that a little later. So that's the way that works. And then we have the final project. It is the last day of finals week. That is mandatory. If you can't make that, don't schedule another class where you have a final then and say, hey, Chris, I'm not going to make that. You do have to go to that. So please plan accordingly. And there's no exams, like I said, which is kind of nice. Okay, last thing before I let you fill out the form. We've got plenty of time. There's just a couple of things that people have worked on, different projects people have worked on. This one was a project where they connected gloves with little sensors on the gloves to Raspberry Pi, and then they could move their fingers around, and it would register and do cool things. Okay. There's another one. There they are demonstrating that. Those are actually like ski gloves or something like that. Somebody built a little chess thing. The thing you're going to read about in a minute is another version of a chess playing game. Okay. And notice, by the way, there's a graphical display back here as well. They had to figure out how to do every pixel on there, and they had to do. And they did that. That was cool. There's the back of their board. It's a little bit of wiring. This one is probably a little more intense than some of the others, but that's a lot of wires, right? Other people did cool things like other graphical fun things like snowflakes and so forth. Somebody built Space Invaders. Okay, this is a little tiny little monitor which they connect. That's a cool project. And then that's that. The first week of class, assignment 0, which we will publish. You need to subscribe to Piazza. You need to watch some Unix videos. CS107 has a bunch of videos that you should go watch for to be able to understand how to use the terminal on your computer. I made most of those videos, so you'll hear me talking to most of them. Please do that and get up to speed a little bit on Unix. The things you have to know are not that many, but you need to know them relatively well by the time you get to the first lab, just to be able to like navigate a little bit. Using Git and GitHub, we talk a little about how to do that. Straightforward for what you need to do. And then submit your lab preference. On the form today, you will check which ones of the labs you can go to. Then we'll also have a form that says which one do you want to go to. Okay. And then there's some basic guides you have to read as well. Okay. This week, you also need to do a bunch of learning for things like binary representation. Like how does binary work? We didn't talk about that much in CS106B at all, really. I will go over a little bit of that next week, or in class on Friday. You need to start to learn that. Hexadecimal is another one. Base 16, which goes digits 0 through 9, A, B, C, D, E, F. You need to know how to use that. Not perfectly, but there's some things that you will need to know. I will go over some of that in class as well. Bit operators. You guys know about and or from like CS106B. You can also do and or on individual bits in a number. In other words, ones and zeros. If you do this, if you take a number like 1011 and you do and, notice it's only one ampersand, and you do 0, 1, 1, 0. If you do and, you use each bit individually and then you and them. In other words, if it's both a 1, it's a 1. If only one is a 1 or it's all zeros, it's a 0. So you do it one at a time. 1 and 0, 1 and 0 is 0. 1 and 1 is 1. 0 and 1 is 0. like that. You need to learn. There's guides for all that. You need to learn that though. What else? That's where you get it from the number.md. You'll see that on thing. We also need to know a little bit about electricity. If you took a physics class in high school or here, you probably did some of this. Not too much to know. You should know Ohm's law. You should know power, how to drive an LED. There's a guide about that as well. Transistors as switches. We're going to use those. You should know a little bit about that. Do not stress it because this is all brand new to you. You will figure it out. And then how to breadboard. Again, you'll figure that out too. Okay. And then Unix command line. Watch the videos. This is how you move files, you list files, you copy programs, and so forth. And there's a guide for that as well. Okay. Now, I'm going to hand out. I'm going to have Matthew and Jennifer and others hand this out, or maybe I'll just hand it out here. Here's the survey. While we're handing out the survey, what questions do you have at this point in the class? Yes.
Is assignment 0 ready to start?
I think we're going to have assignment 0 out today.
Okay.
Yeah, I don't think it's ready quite yet. I mean, it's ready. We just haven't pushed the submit button. Yeah, Matt.
We're going to do labs this week.
Tom said it would be labs this week. We are planning on having lab Friday. I have to figure out if it makes sense to have lab Friday, but that would be the cadence. The Friday is going to be the first, and then Monday is going to be the second. That would be best. So I think we're going to have labs Friday. Yes. Yeah.
Just to confirm, we only have to go to one of the
You only have to go to one lab.
Okay.
Yeah.
What?
All right. Yes.
Projects have to be done in like what number of people?
Oh, good question. So the projects have to be. You can do an individual project if you have a really good one. I would suggest you don't do that. It's not as fun. But well, it could be as fun. But I would suggest doing more. Project teams can be basically 1, 2, 3, or 4. I would rather you stuck to 3 or fewer, just 'cause it makes it easy. If you do a 4-person project, it has to be 4 times as good as like a 1-person project in that sense. So that's it. What other questions do you have? Okay, as you may be deciding whether to take 107E or 107. 107 is happening right now as well, so you don't need to change your schedule if you do decide to take 107. What I would suggest is go onto the CS107 webpage and try to watch the first 107 video. It's actually on video. So you can watch Cynthia Lee do 107, and you can maybe decide if you don't want to take this class. I will assume that you guys are going to take the class based on your surveys. But here's what I'd like you to do. Fill out the survey. You can take the next, we aren't done here until 12:50. So at 12:50, we will collect, you will be in the back hanging out. You could just submit the survey. You can also come back and chat with us. There's a little reading to do, and all we want to know is what you think. Okay? And we also want to know your other details. So as I said, welcome, and we'll grab your surveys, and because you're all here, you guys are in the class. So that's great.